Hello and welcome back to another Common Lisp video. We left this session last month looking at methods, and this is where we're going to pick up on now. I do apologise about the time between videos. Work has been particularly crazy and obviously the world is what it is right now, so finding time for stuff is hard, especially when we're all living at work these days. Anyway, that aside, let's kind of just get into this, and we're going to expand on the methods that we saw previously. And methods, to recap, are completely disconnected from classes. We do not have to write our own classes to use methods. You know, we can just plug into the data types that exist in Common Lisp ourselves, and when we build a class and that gets evaluated, it creates a concrete type of its own, which can be plugged into the methods. So I'm just going to quickly prototype a couple things here. So in the book Practical Common Lisp, which is available at gigamonkeys.com/book, I will leave a link in the video description. An example is used for a bank account, and we'll just set that up. So there we go, we've got our account, and I'm just going to create this. There we go, so we've got our balance there, and I'm just going to put a wee currency symbol in here, and yes, I live in the UK, we do not use euros. There we go, so we've got £0 in our balance there. Now, what we also might want to do is have a overdraft. And it's a type of account. Sorry, forgive me, I'm just throwing some stuff out here that a bank account might have. That seems remarkably high for a current account. There we go, like the 10th of a 10th of a percent. We'll do the same for an overdraft. And I have to imagine that they will accumulate interest from us rather faster than we accumulate interest from them, because that just seems like the way things work. So I'm gonna evaluate this overdraft and this current account. Yeah. just make sure we can get that. So a current account will have a holder, so I'm just going to evaluate and plug all this in and hope this all works as expected. Init form for slot holder, init form, what have I done wrong? Oh, right. Did init form twice when I should have had init arg here. There we go. So we'll take away that. We'll get rid of that, because otherwise this won't work. There we go. So we've got all that in place here. And we have a current account. And we're just going to check the depth there. Oh yeah, because it's the wrong type of account. There we go. Must have a name, of course, so that would have name holder Jane Doe, because I can't think of anything. There we go. So they have a balance of 0 and a debt of 0. And kind of the reason that I'm pointing this out is we need a little bit of a class hierarchy in place to have a look at what we're actually going to do here. And we're going to have a look at an extension to methods and something known as method qualifiers. And let's see that in action. We're going to add our withdraw and deposit methods. So we're going to have a def generic called withdraw, and that takes an account, because we withdraw from an account, and this has documentation, withdraws some balance from account. There we go. There we go, and our deposit function will deposit some money into an account. And we have to write the implementations of these methods. We'll say def method, and we'll say withdraw. And we take away that because we don't want to specify the type, but what we will say is balance, because that's what we need. We need a balance there, or rather an amount. Couldn't figure out if I used 2 M's or 1 M looks fine. So we will then say there we go. Let's also give an account number, just to make things easy. And we're going to just add like an account number here, ACC num. Yeah, that'll do. It doesn't have to be great. So we're just going to have that basic implementation there. So we're going to see that place. Let's set the balance to 500. There we go. And so that all appears to work. We will say withdraw from ACC. I'm going to say 150. There we go. So there we go, we're seeing this withdraw function has been plugged in now, and we will do the same for deposit. And I'm going to change that to the account number. And get rid of that pound sign there. We'll just evaluate both of those again. We'll just check this is working. Withdrawing 150 from there. That's right. And we'll say deposit. I'm depositing 250 into that bank account number. So that's great. So we can see here we've got our classes, we've got our account, we've got this overdraft class, we've got a current account, which is an implementation of an account, and we have a current account with an overdraft, which I would say is an implementation of a current account rather than just an account. There we go, and let's just make sure that continues to work as expected, which it does, which is great. So our current account with an overdraft inherits from current account, which inherits from account, and it inherits from the overdraft class as well. So we can then say, we've seen before in line 32 there, that we can get the debt from the current account with overdraft. So you might wonder, what are we actually, doing with all of this? And what we need to do is we need to have a look at these method qualifiers. Now, that's kind of an extension to these things that we have here. So a method qualifier, there's three types. There is a before, there is an after, and there is an around. And we'll have a look at the before one here. It takes the same name as the generic method it's operating on, but it takes a before thing there, and it takes the same parameters. There we go. And I'm going to start switching over to the actual REPL here, just because there's quite a lot going on now and we kind of want to see more than one thing happening. So if I print this, we get deposit, 250. Oh, I might, of course, want to recompile my methods and run this now, and remove and put a new line there, and of course here, which, to be fair, probably don't need that anymore. So there we go. We have a has that not evaluated? There we go. Just making sure they've all been redefined. I've got a spelling mistake and none of you's told me. Yeah, I know. Okay. So before our withdraw function actually gets called, we can see here in the output that we have this before string printed out, and that enables us to run some arbitrary code before the main withdraw function kicks in. And likewise, we can do the same here. And this might do exactly what you imagine it would. This will now run after. So I'll just get rid of that because we're just focusing on withdraw for now. So we can get that before printed out, we can get that withdraw printed out, we can get that after printed out. And you might wonder, you know, what purpose these serve. And it really allows us to do some prep work before our actual method runs, and maybe some cleanup work after. And the reason that I'm using this example, and the reason I'm borrowing this from the GigaMonkeys book, you know, Practical Common Lisp, is because this is a really, really good example, and I couldn't think of anything better having read it, and it is all out there on the internet. So again, please buy the book. It's definitely worth your time. But what we can do is basically say we could write this. So let's make this a current account overdraft. And we're making sure that this applies to this particular type of class. Well, actually, no. We don't need to. And to be fair, we don't need an after method here. So what I'm going to do is I'm going to recompile this. And run this now. I'm going to change this. If I run this again, we check the overdraft. I'm not sure why we're still getting before there. I'm going to just decompile that and recompile these, so hopefully they have been removed from the interpreter. Yeah, there we go. So I just had to decompile the functions and whatever. So we get this checking overdraft, and then we can do the withdraw function. And what we can do is check to see if there is enough money in that account. So let's say let funds is equal to the minus of balance account amount. Is there anything left over? So we get 350 left over. So if there are funds left over, we can withdraw from the account the amount. And what I'm going to do here is I'm going to implement this, and I'm going to say setf balance account is equal to the minus of balance account. account amount. So I'm just going to recompile that. I'm just going to check. And there we go. So yeah, when we remove 150 from our account, we get a remaining balance of 350. So that is doing what we want it to do. So let's come back to this business here. So if there are funds, we will call the withdraw function. However, if there are insufficient funds, what we need to do is then basically we need to subtract whatever we can from the funds, then anything else gets added to the overdraft. So I'm just having a wee bit of a think here. First off, let's get rid of that. Let's get rid of that, just so I can kind of focus on what it is that we're doing here. So there are £350 remaining. Okay, so then we withdraw from that. Otherwise, let's rename that available balance. And we're going to take that to available balance. I'm going to change that to a when. And I'm going to collapse that down just so it'll compile. Except it didn't. So I'm just going to decompile these again and recompile them. So I'm clearly doing something that it doesn't like. That and run this. Okay. Okay, yeah, so we're overdrawn by £50, right. There we go, it says we're overdrawn by £50. So what we can do then is, if we are basically overdrawn, will then say setf balance debt we're going to add this in here. There we go. So we've got that in place now. So we're like not overdrawn apparently, yeah, because we've not got the logic in place yet. So let's redefine that. So we have a balance of £50 and we're £50 overdrawn. So let's say that when we withdraw, we then basically say if bigger than balance account amount, then we set balance account to be 0, else we just deduct it. If we do this now, there we go. So it took us a little while to get there, I do apologise for that. But we never really know, or I certainly never always know the answers ahead of time. Sometimes it's just figuring out the problem as we go. So what we have here as an example is we have this before method, before we withdraw anything, and we basically go away and calculate some action. So if I change this to 200 and evaluate this, it'll say with an initial balance of 200, if we withdraw 150, we will end up with a balance of 50 with £0 overdrawn. And if I change this to 100 and run this again, we will withdraw £150 from our account, which will set our account to 0 and leave our overdraft at £50. So what this has enabled us to do here with this before method, it has allowed us to do some logic before the withdrawal. Now, not every programming language needs this sort of thing. There are other ways around it. You know, you can put the if checks in the withdraw function and just check to see if we need to do all of this and then do the balance bit afterwards. But what we're actually able to do here with the before and, you know, potentially after methods, we can split the logic up. So we can handle the, in this case, the overdraft stuff in the before, and then handle the balance stuff afterwards. So we calculate what the overdraft is, sort that out, and then just basically sort the account stuff afterwards. And we can take this, and I'm going to add this here. And add an after. And simply just going to say when bigger than 0, debt account, there we go, format T, you are now overdrawn. So I've evaluated that, and when I run this, I think I'm going to have to decompile all of this because it's all gotten out of order. There we go. So let's evaluate this now. Oh, that is really weird. I would have expected that to work. Unless my logic is the wrong way around. Which it probably is, let's be honest. There we go. We can now see that we get this overdraft warning limit, which will go away if I change that. So we withdraw 150 from the account number. It says that we've got £50, and that after method doesn't trigger, because the after method only triggers on current account overdraft class, and it also only triggers, you know, if you are overdrawn. But we can put this logic in place, and although they are related to our withdraw methods, the before runs, then the main method runs, then the after method runs. And I know this is a very simple example. I know, again, I've typed a lot of code here, but the purpose is for us to reason about our code a little bit better, and to maybe put some stuff that we need to pre-calculate, and a little bit of stuff afterwards. I could certainly see where a unit test framework could come in pretty handy here. So if you put all of your tests within a method, or you're testing something, you can do some setup logic and some teardown logic after, which is pretty cool. There's also a way to call the next method. So in fact, if I was to have a withdraw method, a before thing here, so let's say def method withdraw before, and this just triggers on a basic account, not a current account or whatever. And I'm going to copy this as well and just paste this down here. And hopefully this will work. If it doesn't, I'll just, you know, recompile the functions. Yeah, okay, so I'm just going to have to recompile these because it's gotten a little bit out of sync again. There we go. So run this now. We've gotten this after method. Oh, and let's put that back to 100. There we go. So we withdraw from our account. We get now overdrawn. So let's go to this. Ah, yes, I see what we need to do. Oh, I put that in the wrong place. Whoops. It needs to go here. Or it should have done. Maybe if I just do this. Have I put it in the wrong place again? Well, that's weird. It is my impression that I should be able to get the before and after methods triggered, and I'm not sure why they're not working there. You know what? I'm just going to restart the interpreter because things don't appear to be wanting to do what I want them to do. So let's just evaluate all this again. Oh gosh, I've done the wrong thing, haven't I? I bet you saw that as well. I bet you you knew exactly what I was doing wrong. Again, live coding, terrifying thing, fills me with dread. There we go. So we start with this order here, and we start with the least specific method, and that's this before on the standard account, because we get this this word before being printed out right here. And then the next thing that happens is that we call the generalized withdraw on the account, and that's why we get this withdrawing thing. And then the most generic method is called, and then the most specific one is called. So let's put some output here just so we can actually see what's going on. So we've got our after here, and we've got our overdrawn thing here. Let's just sort that out. So when we see this all together here, the most specific before method happens, and then the next most specific. So we could have loads and loads of these going all the way through our class hierarchy, but the most specific before withdraw method kicks in, then the most specific before withdraw method kicks in, then the specific withdraw method kicks in, then the most general after method kicks in, and then the next most general, so becoming more specific. So it starts specific with the before methods and becomes general, and then does the function of method. And then it starts general and works its way out to specific. So we can actually focus on things as they become more general and more specific on the way in and out to the actual method that we're calling. And again, I've never quite seen anything like that in a programming language before, and I wish I had a slightly better example of this, but I wanted to highlight this. There's also an around method, and they would override, a more specific auxiliary method, and that's what these things are called, auxiliary methods. And you can basically plug an around method in, because an around method will happen first before anything else. but you absolutely have to use the call next method business, which you saw me trying to use here because things weren't quite behaving as I wanted them to. But with an around method, it would be a colon around, just like we're doing colon before and colon after, but the around method almost always has to call the next method, and that will trigger the befores. So again, if there's stuff that you want to happen before the before, you can do an around and then kick it off that way. I don't have a particular example to hand yet on how to actually use the arounds, and we have been here for about 40 minutes already anyway, so I'm not going to take up too much more of your time, but to just bring this all to a conclusion here, with this simple account system. I know it's a kind of a boring example, especially when it's about finances, but we can see here all the pieces working together, and really the limit is your imagination about how you want to plug this in. The thing I found difficult, certainly in the why would we bother using this, is it really is a way of separating class-specific logic as you move up and down through your class hierarchy. Yeah, of course, you can just create a method and do everything inside that, or you just build one small function for handling one part of it. And I would imagine it's very similar to how we might choose to create a complex initialization system in something like Python or Java, where we would call the super method and call its super method and its super method to build stuff up, subclassing off of things. But here, because our methods are completely disconnected from our classes and we don't have complex initialization stuff, we actually have the opposite here. We have complex method resolution, and so our methods can just do stuff, change the object, calculate some stuff, pass some stuff into the next method, and so on. Which it's a different way of thinking about it. It's not necessarily good or bad, it is just a different paradigm, a different way in which we can think about structuring chains of function calls or method calls when they're related to objects, especially when our objects here don't have complex initialization things. Function methods, constructors, that's the word, complex constructor chains that we would build. So yeah, thanks very much for watching. I hope this was informative, and do forgive my kind of messing around throughout the code there. Please look after yourselves, and hopefully I will see you in the next video.